Welcome and hello. This is a lesson in WRIMS, and in this lesson, we are going to be talking about inflows, demands, and time series data. What that means is we will learn how to define an inflow and a demand and connect those two to externally created time series datasets in DSS. All right, so let's go ahead and get started. What I have on the screen here is my WRIMS 2, and I've got this L5 inflow demand TS data project already set up. I'm going to begin this lesson by just bringing out a very simple schematic of a water system. So we'll call this a river, 1, 2, and 3, these nodes, where it's flowing in the southward direction or downward direction. We have inflow at the top, entering node 1, and then outflow at the bottom, exiting node 3. Also take note at node 2, there is a diversion that goes to node 4, which is a farm, or more specifically, a demand. So we have an inflow into 1 and a demand at node 4. If I go to the next slide, I've just added a couple labels here, so you can just think of 1, 2, and 3 as a river A. And then I've actually added variable names for the inflow, I1, and then the demand is AW underscore farm. So there's that. And then in the next slide, I've got more to the model I'm going to build and expand on in future lessons. But we're just going to focus on the inflow and the demand for this particular lesson. Now, you may be wondering, why am I using this schematic I just drew out in PowerPoint? And that's because there is a schematic tab here in WRIMS and a schematic editor. I couldn't figure out how to use it. I just haven't found any documentation on that yet. So as soon as I do, you better believe we'll have a lesson. But for now, I'm just going to use PowerPoint. Okay, so back to the IDE tab right here. This is the project directory, which I have right here. There's nothing to it except a launch file and a .project file. I'm going to set up my file structure in such a way so it's easy for me to navigate. And on the screen now is the project directory I want to set up. So here is the directory here called project. We already have these two files at the bottom. I want to create a DSS folder with 3 DSS files, and then a run folder with my main Russell file, and then a system directory, which will contain a Russell file for my demands and my inflows. So let's go ahead and get started on building these, rows 34 through 42. I'm going to go ahead and just build them directly into WRIMS using the IDE controls. So here's the project. I'm going to go right click, new, folder. So I need a folder called DSS. It's going to go into my project directory here for L5, lesson 5, finish. I also want to add a directory for run. So right click, new, folder, call this run, and then finish. Okay, within DSS, inside this folder, I want to add 3 DSS files. So I'm going to go right click, new, file, call this dv.dss. Okay, so it opens up DSS view automatically for me. I'm just going to close that. It's probably going to happen a couple more times here, but new file. This is going to be now for state variable.dss. Okay, close that. And then one more for the initialization, which is new file init.dss. Okay, so those files are ready to go. We'll return to the state variable file in just a moment. Next, in run, what I want to do is create a file. I'm going to name that main.russell and then finish. Okay, and then I want a folder that's called system. So right click, new folder, system, and then that's going to go inside the run directory because that's selected, and finish. Okay. And then within system, that's where I want to create my ARCS demand and ARCS inflow Russell files for defining those inflows and demands. So right click, new file, and then within system, call the first one arc demands.russell, finish. It looks like it opened up for me right here. That's fine. And then the second one right here, I'll go right click, new file, and then arcs inflows.russell and finish. Okay. Now at the moment, you may see a little red X next to these icons. I think that just means that there's some sort of validation or error checking that's taking place, which is probably a setting somewhere up in my Eclipse. So I could probably toggle that on off once I find it. But for now, it's fine. It just basically means we want some data in these Russell files. So let's go ahead and give it what it wants. Let's start with arcs demands. That's this first file here, arcs demands.russell. I'm going to just type in or paste in the demand, it's going to be called AW underscore farm or applied water farm. And the units are going to be in CFS. So we're going to be dealing with flow rate here for all of our state variables. These are state variables. And yeah, the state variables are mentioned in the Russell Plus language reference. This is, I can show you where this is downloadable, but it's about 30 pages. It talks about state variables for a couple pages here. State variables are used to hold information that may be used in expressions within subsequent state variable assignments, goal statements, objective functions, and so on. For us, we're going to use both the demand and the inflow will fall in this category of state variable, and we will be referencing the sv.dss file when selecting a time series. There is a few different examples here. We're not going to go into too much in this lesson, but state variables, you can just define a variable and give it a value. That's the simple method. You can use this sum value where it sums up a number of values together. And then also there's a lookup table type of state variable, as well as a conditional value type of state variable. Okay, where you can find that is in the description of this video. I'm going to leave a link to Calcium 3 documentation. You go down to session 1 intro over here on the left, and then click on this supplemental readings. And then that Russell Plus language reference is this PDF file right here. So just go ahead and click to download. Okay. All right. So back to our ARCS demands. This is our only demand, right? We only had one inflow and one demand. Let's go ahead and define our inflow, and then we will do all the DSS data work at the same time for both the demand and the inflow. So I'll click on this tab here for the file ARCS inflow. And just like the demands, I can type in or paste in what I have prepared. So the inflow is going to be called I_1. It's a time series type. It's going to be called inflow for type part C, and then the units will be in CFS. Okay. So the variable name right here, which is I_1 for inflow, and then for the demand, it's AW_ farm. That's going to be part B in the DSS path name, part B. And then the kind right here, applied water, this is going to reference the state variable, the path name part C. So we got part B and part C. And then so for ARC inflows, it would be part B and inflow would be part C. Okay, let's head over to DSS view and actually define this data now. I'm going to do a Control S to save both of these files. And then over here in the left, you notice that we don't have any red X's that identify incomplete or invalid data. All right, so here's DSS view. It's up on the screen. If you don't have DSS view installed already, it's a program put out by the HEC, and one of the links in the description takes you to that download page. All right, so, and there's also a playlist of DSS view videos on this YouTube channel somewhere. So knock yourself out with learning how this works. But what you need to know in this lesson is we're going to open up the sv.dss file that we created earlier. So I'm going to go up to File, Open. Here is our project directory. And if I click on DSS, here are the 3 DSS files that we created at the beginning of the lesson. SV is going to have our state variables, and then click on Open. Okay, it currently says there's no paths, which means there's like no data within this file yet. We're going to add a couple paths though. And what we're going to do is keep it real simple. I'm going to bring up the model schematic once again. And what I'm going to do is define monthly time series data for both the inflow and the demand over the course of a 12-month period. So it's just going to be one water year, and it's going to be a constant number. So for instance, if the inflow was 12 CFS, and then the farm demand was, say, 5 CFS, then we know we'd have 12, 5, and then the difference would be 7 that continues downstream in the river. I'm not even going to change the numbers, so we're just going to keep it real simple and use constant values. Let's work on the demand first. That's AW_farm. So with sv.dss selected, we have our state variable.dss file selected. Go up to Data, Manual Time Series. Let me resize this. And then we can type in our path name parts, but I have it saved on my clipboard for the full path name. So I'm just going to paste that in and then click Tab. For part A, it says Project. Part B and C, this is critical for matching up with that demand. We have AW farm and then applied dash water. So make sure that those two are spelled correctly and consistent with what we typed in the arcs demand.russell file. For part E, I put 1 month, and then for part F, I just put state. Below that, we have the start date, which is going to be the first month of water year 22. The start time, I'll say, is 2400 hours. The units is CFS. And then the type, I'm going to say this is period average. All right. Now, like I said, I'm just going to say this is a constant 5 CFS. So I'm just going to give the numbers 5 by typing it in here. So I went 1 over, and that's fine. Then I'll go ahead and click on save, and then no. Okay, so one path is done, one more to go. So let's go ahead and add a time series data set to represent the inflow. As before, I'm going to go up to data, manual time series, and then I'll just paste in the path name parts, click tab, and then those pop into place. It basically just parses off the slash character. The variable is I_1, the inflow into junction 1 or node 1. And then part C here is inflow. That's the type. So just to reinforce what I'm talking about, here's the inflow tab. Here's I1. Part B, here's inflow, which is the kind. I'm sorry, kind is so part B in part C. And then just with demands, we have part B and part C. Okay, back to DSS view. The start date, I'm just going to use the exact same data as we did with the demands. So the units are in CFS, and then the type is going to be period average. So I'm going to say this is, what did I say, 12 or 13? 12? 12. I'll just keep typing 12 for a constant 12 CFS for the entire year. Okay. And then we'll click save. No, we don't want to re-enter the edit screen. And then just looking at the data in a table, here's a constant 5 CFS demand and a constant 12 CFS inflow. We can also plot that data, and it's pretty boring, just a constant 12 CFS for the inflow and 5 for the demand. Now, you may be wondering how these state variables are read in besides just part B and part C, and the answer is going to be in this launch file right here. We have launch file _.launch. So if I go right click and then run as, and then run configuration, and then I click on this launch file, we see that the state variable is referenced right here. This is a relative link to the svar file. So it's in the DSS folder, sv.dss. So that sort of completes the connection between the file and the data. All right, well, that was it for this lesson. What we talked about was adding a demand and inflow to our water model. Here's the schematic once again. And then we used DSS view to create a time series data set for both the demand and the inflow and connected it using parts B and C.